Hello everyone, my name is Yogesh. In today's video, I will explain you how you can clear your SQL Server DBA interview. And this session will be very much important for all the experienced DBA because especially there are a lot of expectation of a company from them. So this video will tell you like how you can present the most important part of your you can say experience and in a better way. I won't be covering much of this. You can say examples. I will be covering few examples so that you can become friendly with the topics which I am covering. In detail, I usually give the training especially for that. But this one, I am expecting you to know all those things. If you doesn't know, still it will be a good introduction for you so that you can explore more. So now starting with like from as you know like from fresher companies are not expecting much, but from the experienced DBA they expect a lot of things. What are the common things? One is they should be experienced in all the common DB operation like backup, setting up user, installation, upgradation, and those other things. And then coming to the experience in always on, you can say, and experience in disaster recovery and setting up readable secondary mirroring and those kind of things. And then there is a good knowledge in SSIS. SSIS has become almost mandatory. It's not just the part of BA nowadays because all DB are expected to know, but still if you doesn't know, still it can work in most of the companies. And one specific requirement is performance optimization. If you search today, 90% of the job requirement is you should be good at performance optimization. And here is the crux, because all company data is increasing and the performance is degrading. So if you can tell them like you are the best person for performance optimization, it will give you a lot of, you can say, it will give a lot of appreciation to your resume and your experience, and you will get selected. And that's the crux of your, you can say, total interview. So it's all on you how you present it. So today's video I will be giving you the script, what you need to speak, and what are the topics I will be covering, and a few examples to it so that you can be friendly with it, what does actually that means. And then once you know these things, you need to prepare, learn. I Because it's not like that you just read the script and go and get the job, because even if you get the job, it will be very difficult to do the work. So you need to know these things. So that's the main crux of it. So starting with like, what is performance optimization? Now the performance optimization, I will start with a basic example. So let me show you one example so that you can understand it. So I have this, you can say, pre-prepared few examples. So I'll show you a simple example. So here, let me just say, let's set test IO comma time on. So what I'm doing is I'm just executing this simple script. What this script is doing, that doesn't matter. Just the performance optimization matter, and you need to know like what is the execution plan. Okay, let me select the execution plan also so that you can get a small insight about it. Okay, and let me execute this query parallel in a different tab, and I will use the same set statistics IO and time on. I hope you know this statistics IO and time on. It just to know like what is the input, output, and the time. Believe me, this is not a session. I'm just getting you introduced with the concept. Okay, so if you see, this query got executed in less than a second, and it gives me 384 records. Doesn't matter what are those 384 records. And the execution plan, if you see, it seems very simple. Okay, so let us just wait for this query to complete. Okay, because the first topic which I am trying to show you is called as spooling. So spooling is one of the main operator which, whenever you are doing a performance optimization, you need to first look for all the queries, which expensive query which are having spooling into it, because spooling usually have a great scope of improvement, and spooling is, you can say, the most expensive operator in any execution plan. I will give you an example about it. So now my first query got executed completely, and let's me go into the message and see how many logical reads. So for the student table, I did 3,456 you can say scans, and then I have done like 2,100,090 2100 195 502 scans. So this is a pretty massive number, and the number of records, if you see, it's 384. And if you notice in this execution plan, let me zoom in. So there is something called as lazy spool. Lazy spool is one of the main expensive operator. Any execution plan has it. You can optimize it. Okay, so 384 records, the same query which executed less than 1 seconds, I am able to So the same query which took around 54 seconds, I am able to execute in less than 1 second, and it depends upon how I fix it. So the first topic, I'm not explaining you how lazy spool work and other thing, because you are DB, I'm expecting you to know that. But because this topic is mainly not to teach you the performance optimization, it's more about what you will say about the optimization. So now suppose you are giving your introduction saying, my name is Yogesh, I am from this place, I got my graduation in 2012, I started working with X and YZ company, and so thing. And then you can say like, in most of my work experience, my main focus has been on performance optimization. I'm very good at it. Now the moment you say, the person will, if suppose that is the person who is taking your interview is a project manager, and he knows there is a performance problem in his project, for sure he will be asking how you solve it. So now the real part comes in. So the first thing is like, first we try to find, so you can start with saying like, first we try to find expensive queries, as 99% of the performance issues are because of the bad queries, and this is real case. Believe I, in my whole experience, a lot of companies, people from YouTube contact me saying like, my server is not working well, and when I ask what is the size of database, they will be like 2 GB of database. What is the size of RAM? It's like 16 GB. Server is 8 core or 16 cores, and still they have performance problem too with 2 GB of database, and that's because of the badly written queries. So 99% of the time the performance issue is the bad written queries. 1% is chance it's because of wrong configuration or because of the hardware issue. My case has been like with the hardware issue, where the hard disk was not working properly. I never seen configuration that much wrong, like it will cause a performance issue. Or it can be with the, you can say, patches also, because in 2016 SQL Server, till the time they given update 7, there was some memory leak issues. Okay, coming toward this, so first you can start with like, first we try to find the expensive queries, as 99% of the performance issues are caused because of bad queries. So once we know the bad queries, so now you will explain how you fix those queries. So once and remember one thing, this is all about how you will explain your interview. Now you can say like, no one single query affect your server, because suppose there is a very long running query, it took 3 hours to run, but you are executing that query once in a month, so it doesn't matter, it can run in a night hours when the server is not that heavy loaded and those kind of things. It's all about, if your server constantly be on 99% of the usage or 100% of the usage, then there is a problem. And that not only one query be responsible for that, multiple queries get into it. So 99% of the performance problem is because of the bad queries, and how you fix it. So first I try to find, is there any lazy spool? If there is a lazy spool, I try to fix it. Now what is lazy spool? Lazy spool is the most expensive operator among all, which happens because of duplicate aggregation. Now let me explain you a simple example what I covered. So in this example, what I've done is, so I have the student table. What I was doing was, I was getting the date, year of the student when he was born, and I was trying to get the maximum date of birth in that year from the student table. So what happened, for suppose there are 10 students in 1991, so for 10 student it will ask for the maximum DOB. Now all are born in the same year, so for sure the output of this query will be the same, because 1991 10 people born in the same table, there will be only one maximum date for that year. So even though there are millions of students, still there will be only one maximum DOB. So in that case what happens, I will be executing this million times or number of times the student are there for the same year. So this is duplicate aggregation. When there is a duplicate aggregation, what SQL Server do is, it forces spooling, and most of the time it's lazy spooling. There are other spooling also, eager spooling and other spoolings also, but the main thing is lazy. Lazy spool is, here it shows like 1% of the CPU usage, but if you notice in back of it, so this is only 1%, but in the back 56% plus 42%, which make around 98%, and 1% make 99. So if you see, this part of the query is the 99% of your performance problem. So if you fix this part, and you will be good. So why lazy spool comes, it comes up because of duplicate aggregation. And how I removed it, in this example I used a CT. Instead of doing that, first I got the year and the maximum DOB, date of birth in that year, and then I made a join with the student table to get the student who were born in that with the maximum DOB, who were the, you can say, most youngest student of that year. So let's coming back to the document. So what I said is, lazy spool is most expensive operator among all, which happens because of the duplicate aggregation. Remove aggregation using temporary tables, CT, table variable, etc. So whatever you want to do, you can do it. So how you are starting with, you are saying nine because of the queries you are having performance problem, and how to solve the queries. First operator is the lazy spool. If there is a spooling happening in the your query, first we try to remove it. How we remove it? Using temporary table and CT, because lazy spool is very bad. If you notice here, it took 54 seconds and we executed in less than 1 second. So there is for sure 5400 times, you can say 54 times it's better than uh, original query. And also let's go to the logical reads. Now logical read for this query is 2 is the scan and 1272 is the logical reads. And here what was that? It was in like 6 digit. Yeah, it's 7 digit. It's not even 6 digit, and the 4 digit was the scan count. Now if you notice, suppose I execute this query 100 times on the server and it is doing that many logical read, for sure it will, my server will be using a lot of CPU. Now suppose I run this query 100 times, the logical reads are less, it has to read less memory, so the performance will be far better. So vice versa, it's like if you reduce the logical reads in your query, for sure there will be a performance improvement. So what I'm trying to say is, this lazy spool has that big impact, like it from 7 digit it brings to the 4 digit number of the logical read. So the first expensive operator what you try to find and solve in a query is the lazy spool. Suppose you have 10 100, you can say 100 expensive queries, you figure it out, 10 has the lazy spool, first try to fix them because it's easy most of the cases. But not in all the cases you will be able to remove, because especially when you are using recursive CT you cannot remove it by the chance, by default they come there. Okay, now coming to the second operator. So first operator is, first you look for the list pool, then you look for the hash match. Now hash match is kind of a cunning thing, it's not that simple, it's not one formula to fix it. So hash match usually happen, which is always because of unsorted data. Suppose you are joining table A with B and A, so you are joining on the foreign key. Now suppose there is no index on the foreign key, so there is no sorted data on the other side. So when you join, it has to sort the data. So how SQL Server does? First it calculates the hash, sort the data, and then join them. So that becomes an like you can say extra expensive operation for the your SQL Server. So how you can fix it? First, which means either missing index or not, or there are indexes but not properly utilized. I will explain you what that means. So I have function. So when you are joining with function also, that can be one of the main reason. So let's see this example. So this example we solve, still you see there is a missing index suggestion. Okay, now here you notice like 1272. So if I create my index, let's see whether it will improve my performance more or not. So I will say, let me say student idx, I will just create an index and run the same query. Now you have to notice my scan is like 4 digit. Now let me run the same query. Now I've created the index. Now if I go, my scan is reduced to 3 digit. It's totally half, like from 1272 it becomes like 673, so it's almost half. Scan has increased, doesn't matter because the data size is small, so scanning doesn't matter. And the execution plan got changed. Okay, now let me just drop the index again and we'll see what does that mean. Or even I can fix that without that, like the date and d comma 0 comma this. So let me just run it again. Now here is okay. Now yeah, now wait a second, let me just add this again and see if this works, else I have to drop the index usually, because data is lesser in that cases also it can do. Okay, so here you see, so there is a hash match join. Why? Because student I'm joining with CTE. Now when I'm joining with CTE, so CTE doesn't have any sorted data by default, and also student doesn't have any index, so it is adding, you can say joining two columns which are both unsorted. So in that case what it has to do, it has to sort them before making a join. So there is a hash match operator. If you cannot see, let me zoom it out. So this is a hash match operator. So what I've done is I created an index. So as there is an index, there is a sorted data. So by default, it will go for hash. You can say nested loop or merge join, which will be far better than the hash match. And the join got converted into nested. So it's very simple. So one is the index is missing. The second is when we don't properly utilize the index. Now I just added one function date add, and I added 0 dates to my date. So this won't be practically there, but just example, I'm using any expression on the join column. So even though there is an index, still my query won't be able to utilize that index. Again, went to hash match. Even though index is there, still using the index, still it is unable to see. The reason is, as I used a function on my column, it make undeterministic for your, you can say, SQL Server to determine the outcome. So it goes for again hash match. So you should always confirm whether index is there. If it is, the index is already there, then you have to make sure you are you should optimize your query to use that index. Okay, so now coming to this, so how your answer is like, I do how I perform do a performance optim. Why I will be keep on repeating the same thing so that you can learn. So how I do is like, first I confirm which are the expensive queries, then I try to see which queries has the lazy spooling happening. If the spooling is happening, I try to remove them using temporary table and views or CTs. Once I do that, then I look for the hash match. If there are hash match, then I try to see why the hash match is happening. It can be because of the missing index, or it can be because of the you can say some expression used on the column which is not utilizing index properly. So I try to fix that with that. Okay, now coming to the key lookup. Key lookup is very simple. I think almost, I don't need to show the example. So key lookup is nothing but, suppose in this index which I just created, I remove this first name and last name. I keep only on DOB. So what will happen is, for first name and last name, it has to again go to the you can say cluster index to get the data. So key lookup is something like where you have missing columns from the index. So here 3 columns are there. If I just remove one column, then it has to go for key lookup to get the third column, because the index only contains 2 data. So key lookup you can solve by adding you can say more keys or more include columns to the index, but a lot of time that becomes you can say very difficult to do that, because suppose SQL Server may give you a suggestion saying like add all the columns to the index, and that's practically invisible, like it's not good also, because it is like duplication of table. So key lookup is sometimes like you have a big table, you have index, and only one column is missing, and there is no harm in adding it because it's increasing the, you can say, your performance. Then you can go for a key lookup, you can fix the key lookup. So the first preference is lazy spool, second preference is you can say hashman, and third preference is like key lookups. Okay, indexation also, like you need to know, like when we create the index, I hope you all people know like what does we mean by index key and the include column. So if I say add new non-index, so there are 2 parts. One is key column and the include column. A lot of times I have seen DBA doesn't know what both this mean. So if I add a column into, let's say, key part, and then I add a column to the include part. So the difference between both the part is, in key part the data has to be sorted. In include part it need not to be sorted, so it will be saved as it is. So include column, if you have like a column which are part of select, so in a query, if I break down the query has 3 parts. One is select, and the data column between select and from, and then after from there is a table, and then there is a where clause. So the where clause column should always be key, and include column should always be the selection one which you are just selecting, like first name last name. There is no query which is running on first name last name, all are running on the DOB. So DOB will be the key, and the include column will be the first name last name. So just wanted to explain, that's why I explained. Okay, now coming to the next topic, that is called as partition elimination. Now after lazy spool, if your database or your tables are partitioned, believe me, this will do a magic on your tables. A lot of times I have seen the companies has partitioned their data, but still partition elimination doesn't happen. So I won't be explaining. So this is the just few steps of creating partition. So I won't be going through that because you can learn about partitioning on YouTube like hell. Because if you just search partitioning SQL Server, you will get million videos out there. But I will explain you like what does that mean. So I have one table called order details, which is partition on you can say order date, order details, which is partition on order date. So I will be searching the data between these two. So if I run my query and see the execution plan, So let's see the logical read. So I have 25 counts, scan counts, and 46 logical reads. The table is small, it's not that big, so I just wanted to show. So now if I go in my execution plan and I click and go to the properties, let's say go to the properties, and I select my table, like this is order details. So here you see there is something called the actual partition. So how many partition it has to scan? This table is small, it has only 25 partition, and this is telling me the total partition used to get the rate is 25, and the range is like 1 to 25. This dot means 1 to 25. This is what SQL is telling us. I have already partitioned this table. Why it has to scan through all the, you can say, column, even though the partition is on the order date. Now I will run the same query, the same order details. Just one thing I'm doing is I'm casting the data, like the parameters. Now if I run my query and I see, and let's go to the execution plan, click on my table, see execution plan got changed. And here you see actual number of partition it used 2. And what are those partition? 3 to 4. So here you see, instead of scanning like 25 partition, it only scanned 2 partition to get you the data. And that is also seek, not even scan. Now if I go into my logical reads, how much they were, like I forgot, I think something 42, but now if you see the logical read is 4. So it's like reduced drastically. I will give you my like you can say, I will explain like what in my experience also there was a case where we reduced a query from 90 minutes to 10 seconds, and it was all possible because of two things. One is removing lazy spools, and second, partition elimination. Partition elimination was, you can say, the biggest part of it. With lazy spool I was able to reduce it to like 10 minutes, 20 minutes, but from 10 minutes to seconds it this partition elimination break, because this was not happening. And how this partition elimination doesn't happen, if you notice, the column data type in the table is date time, but the parameter I'm passing is datetime too. Now it seems very silly, but it matters a lot. Okay, so it matters a lot. So in partition elimination, first thing is you check whether the data type of parameter and the column is matching or not. And second thing, now here what I do is I will do the same thing, date add d comma 0, add 0 date, and I run my query again and see what will happen to the partitions. Oh, sorry, I did a mistake. I forgot the syntax. Okay, let me just run it again. Oh man, what has happened? Okay, one more bracket. Sorry. Oh, let's run it again. And let me see the execution plan. Now here you see, okay, it didn't change. Let's say 1 plus minus 2. Let's say like this. Let me just give a try if this make a difference. No, it's not working. Okay, so what I was trying to say is, like, sometimes, like, if someone is using expression on the index, like in the column, the parameter. Oh no, no, not on this parameter. Oh man, I did it wrong. So let's say I just added this function onto the column, not on the parameter. Now if I run, because parameter is a computed value, so it won't have a difference. So if I click on now, so here you see, instead of 25 it's scanned 23, because the first column data type was matching. The second time what happened is, the second condition, I put an expression on the column and try to run my condition. So as I'm using an expression, what it made is it made it undeterministic. So what SQL Server did is it went through all the columns to all the partitions after 3, because first 2 partition got filtered by this, but after that other partition it all took. So this thing matter a lot, like partition elimination, whether first of all data types are matching or not, or secondly, are we doing any, you can say, arithmetic operation or a logical operator, like a logical, not a logical operator, arithmetic operation on the column itself, which is the partition key. If that is the case, we have to avoid it to make the partition elimination happen. So let us see what we have learned. So what you are saying, what you have to say is, like, in performance optimization, first we figure out the expensive query. Once expensive queries are there, first we see whether there is a lazy spool or not. If lazy spool is there, it is because of the duplicate aggregation, so we try to fix it by adding temporary table and the views, or you can say CTs. Then we check for hash match. If there is a missing index, or that comes because of unsorted data, means either there is a missing index, or the index is there but it is not getting properly used because of the some expression done on the column. So we try to fix it if it is on the query level, or we try to add an index. Then coming to the key lookup. In key lookup means there is some missing column in the index. It's not always possible to add all the columns to the index, so we try to see if it is one column and it doesn't harm, then we can add. To avoid, you can say, uh, key operator to get that extra column which is not part of the index. Now the last, not the least, is the partition elimination. If there is a partitioning on the table and the queries are unable to eliminate the partition, then we have to see why it is not happening. It can be because of the data type mismatch between the partition column and the parameter passed, or an expression used on the partition column, you can say the key column. Okay, so I hope I explained you well. Now other few small topics are, like, one is bad views. Now bad views is very simple thing. Let me just explain you with an example. Yeah, so I created a view called order, this product view, and this is my query, which if I execute, it's very simple query getting me few columns, and the execution plan looks very simple: 1 2 3, let's say, like over 2 stages, because these two are on the same level. Okay, now I created a product view. Now this view has the same exact query, but it has one column less than the this one. So here the quantity is there, here there is no quantity. And if I see the execution plan, it's exactly the same, because even it is not having that one column in the output, still the execution plan remains same. Now a lot of time what people do is, once they create the view, now suppose I want a quantity column, what they will do is, instead of joining it, altering a view or adding a new view, they will join it with order details table again, just to get that unit and the quantity thing, and made a join. When this happened, let's see what happened to the execution plan. It added one more layer to it, because view doesn't contain that column. For that column, getting that column, you added the table again to join, so it has to revisit the table. So it adds more logical read. So here you see the logical read will be more than the origin, this query. So whenever there is an, you can say, extra column required in the, you can say, view, so instead of joining the same table back to the view, instead of doing that, either alter the view or add a new view and use that. So bad views sometimes play a major role in the performance problem. I have seen them, so those has been a big problem. So you always try to resolve that by altering the view or adding a new view. Then coming to the minimizing subqueries. Minimizing subqueries is very simple. So this is the best example to it. Suppose you have to get all the you can say customers and their most recent order, not all the orders, most recent order and amount of it, and who shipped the order. So if you see, you cannot get it very easily, because it's not the straightforward join. Because if you do the join, you will get all the orders, but as I told you, you only need to get the most recent order. A lot of people say I will do a you can say max of order ID, but what if I need other columns also? So in that case, what people do is they use a subquery, like, get me the order ID where this customer is there, order by order ID descending, and top one means get the most recent. The similar way I will get the freight, similar way I will get the ship. Now suppose I need 20 more columns, I will keep on adding these subqueries. Okay, so one thing is, like, my speed maybe you can say fast. The reason is I am not teaching you these things, I am just explaining you how you will present in your interview. For this, you can say, if you want to learn, you can ping me. I usually provide training especially for the DBS for that. But else you can just google these topics, whatever I'm teaching you. It's there is a lot of content available now. Okay, coming back to the subquery. So if I need 20 more columns, I will add this 20 more subqueries. So how you reduce it? You can reduce it by simple using a cross apply, like, not always the cross apply, but it's more like you have to remove the you can say subqueries. So here in the cross apply, I executed the query once and got all the columns. Now if I need more 20 column, I could just add into the same query. I don't have to uh, again and again type the query to do that. So minimizing subqueries make a lot of difference. So if I just execute both, let's see how much is the difference. So the first query is 71% of the batch and this is 29% of the batch. And suppose I need to get other columns also. Give an example. So if I add, let's say from order, I need to get order date. Let's say order date. I will get one more column. And now if I run again both the queries, and I will add, wait a second, order date here also, order date. Oh man, sorry. And I run both the queries again. And I see now the percentage got increased because for one more query, I to getting one more column, I added one more subquery, and the you can say costing for this one got decreased. The reason is because in my this case, I can get all the columns from the same table without adding any join or anything. So it's far more cheaper than that one. Okay. So then the last is minimizing subquery, and then coming to non-searchable queries. Non-searchable queries nothing but making your query not searchable. The best example was, as I showed you, we added one expression into our, I think here also I showed you. So if I add a date add expression here, date add d1 or 0 comma, and I try to run this. Now what will happen is it will produce an hash match, and hash match, because what happens, index was there, it is unsorted data, either index was there, it was not properly utilized. So these expression makes your query non-searchable. Non-searchable means search argument, because it makes SQL Server, because this is a search argument. The reason is because this is a where clause. So what your expression does, it make undetermined, like it may so SQL Server get confused like what will be the outcome, so it goes for the other non, you can say scan kind of operation. So in that case your query become non-searchable, or using wildcard like this, like percentage xyz percentage. So if it is like xyz and then percentage, it's okay, but if it is like percentage xyz, then it becomes a problematic. So in that case also it becomes non-searchable. So these are the pretty much topics which can give you a very good insight about the performance optimization. So what we learned is, you will tell like the way I used to solve the queries: first finding lazy spooling, if they're fix it by temporary tables or CTs or any other thing, because lazy spool are nothing but duplicate aggregation. Aggregation is expensive operator, and when it becomes duplicate, then it becomes more expensive. Then using hash match, fixing hash match by creating index or by altering existing index, or by changing our queries by seeing if there is any expression happening on the key column or not. Then using like trying to remove key lookup. And after this, least but most important, if table is partition, seeing whether the partition elimination is happening or not. If it is not happening, fix it. Usually the case is the data type of parameter in the column is not matching up. uh, and second is like again using non-searchable queries on the column, on the key partition column, by using date add or other function, not to use that. Bad views are like this view doesn't contain few columns, so instead of creating a new view, people try to join the same table again, increase more logical read. So that's what the bad views are. Then minimizing subquery using cross apply or any other operator, where instead of computing multiple subquery, I can compute it once and use it multiple times. And then the removing non-searchable queries. So this was like all about the performance optimization. I can just go you through walk you through the slides. So this is my, you can say, session content. Usually this is what I explain, like first how to analyze execution plan, how to see statistics, spooling, hash match, key lookup, bad views, subquery minimization, partition elimination, searchable queries, index, scan, and seek. So these are the topic I usually cover in my training. So that's what I showed you. Like, so I will be actually posting this script into the link in the description of video. You can get this from there, or you can just mail me on my email ID, that's yogesh.mail@gmail.com. You can reach me on WhatsApp also, and Skype also. Skype, let me just put the Skype email ID also. Sorry. So my Skype is same yogesh.mehla@live.com. So Skype also you can contact me if you have any other questions. So hope this session would have helped you, because what I notice is like DBA doesn't offer performance optimization to the company. So either company doesn't find any DBA, so they will choose you, or they will choose the person who has given an answer to the performance optimization. Believe me, if you can include performance optimization in your introduction, and the person who is taking your interview get interested in the performance optimization, and you answer this way, believe me, you will get selected. Because I do a lot of consultation. I have made a lot of people to clear their interview by giving them training and how to present it. I hope this video would have helped you. If you have any questions, please put in comments, or just mail me, or reach me on Skype or WhatsApp also. That will work well. Thank you. See you later.